Hello, welcome back to the channel. So let's continue our previous question. And if you watched my previous video, you know that we solved only the first part of this question. And since we only solved the first part of the question in the last video, we'll solve the rest three parts of this question in this video. So if you have not watched my previous video, I would highly suggest you to watch that video first in order to get the full context of this video, because we'll use the answers we calculated in the last video in this question, in the following parts of this question, right? So I'll give a basic idea about the question. So the question was about the volume calculation of an oblate spheroid which is formed by rotating an ellipse, the upper part of the ellipse, around the x-axis. So we were given this equation, we were given this elliptical equation, and we had to rotate. We had to first sketch the graph of this ellipse and then rotate this ellipse, the upper part of the ellipse, the upper half of the ellipse, which was the positive half of the ellipse. We had to rotate the part above the x-axis. So that is what we did. We had this upper half of the ellipse and we rotated. When we rotated this ellipse about the x-axis, we realized that we were forming circles which were stacked onto the sides of each other. So in order to calculate the volume, we calculated an arbitrary aerial strip, the area of an arbitrary aerial strip, which was the area of a circle of radius this, and then after calculating the area of the aerial strip, we'll calculate the volume by plugging in the endpoints into this equation, right? So this was the basic idea about the volume calculation of this question, which was related to the volume calculation of the shape of the earth in this case. So now this was the most important part in this question, but sometimes there can also be simple questions asked as a continuation to the volume calculation questions over here, and that is what we'll do in this video. So we calculated the volume of the oblate spheroid. Now let's move on to the next parts of this question, and these questions, the next parts would be pretty simple if you calculated the answer. If you know how the answer to the first part was calculated, the next questions calculations will be pretty much simple if you know the idea about the basic volume calculation of the shape of the earth using definite integrals. So now the next question is, suppose the earth has the radius at the equator 6378.137 kilometers and the radius at the poles is this one. If we model the earth as an oblate spheroid formed by rotating the upper half of the ellipse about the x-axis, so we know that we are rotating the upper half of this ellipse, the same ellipse that we rotated in the previous part. We have to rotate it about the x-axis, and then if we do this thing, we have to find the values of a and b in this case, right? So now in order to solve this question, we'll use the given information in the question, which was this one. So an oblate spheroid is formed by rotating an ellipse about its minor axis. So that is why we have 1 by a less than equal to 1 by b, which we also observed in the last video. So since 1 by a is less than 1 by b, so the radius which would be shorter is 1 by a, and the radius which would be bigger is 1 by b in this case. So that is why the shortest radius of the ellipse is 1 by a, the largest is 1 by b. So 1 by a would be 6356.72, because this is smaller than 6378.137, right? So that is why 1 by a would be this and 1 by b would be this. So if you'll calculate a and b, you'll get this answer. You can leave the answer as it is and you don't have to do the complete calculations in this case. So this was the part B of the same question, a fairly simple question, right? And now we have to calculate the volume of this model of the earth. In order to calculate the volume of this model of the earth, we knew we were calculating this definite integral, right? So if you'll solve this definite integral, you will be able to calculate the volume of the earth, because this expression was again calculating the volume of the solid formed by rotating the upper half of the ellipse about the x-axis, right? So if you'll calculate this definite integral, you'll calculate the volume of the earth, and then you have to plug in the values of a and b after solving the volume. So that is why when you'll solve this definite integral, you'll get this expression at the end, 4 pi by 3 b square a, and we already know the values of b and a. If we plug in the values of b and a, we'll get the volume of the earth in this case, which would be this one over here. Again, a very simple question, right? So that is why if you know the approach on how to solve the main part of this question, you'll easily solve these type of questions which are in continuation to the main part of this question. So now let's move on to the last question, which is about errors. So now suppose we had calculated the volume of the earth by modeling it as a sphere of radius this one, and we know the volume of the sphere is 4 by 3 pi r cube. And now based on this information, if we suppose the volume of the earth to be the volume of a sphere, what would our absolute and relative errors be compared to our oblate spheroid calculation? So whatever volume you got over here is the actual volume, right? The question is asking, if you assumed your volume of the earth to be a volume of the sphere of radius this one, what would be the absolute error? So you know the absolute error is the original value minus the calculated value, right? And we know that the original value is this one, the actual value, right? So the actual value is this one and the calculated value would be this one. So that is why if you'll calculate the absolute error, you just have to subtract the actual volume with the calculated volume based on the information given in this question. And since we are calculating absolute error, it would be an absolute value in this case. So if you'll calculate the absolute error in the volume, it would be this one. And we already know in order to calculate the relative error, we basically divide our absolute error with the actual value in this case. So in this case, since the actual value is the actual volume, we will divide this absolute error with the actual volume, which is calculated by this formula, right? Which is already calculated in the third part of this question. So that is why if you'll calculate relative error, it would be absolute error divided by actual value. This is your absolute error, the same as over here. If you'll divide the absolute error by the actual value, you'll get 0.00336, and if you convert it into a percentage, it would be 0.336% or about 1/3 of 1% relative error in this case, right? So that's it for this video. In this video, we solved some follow-up questions which can be asked in addition to the volume calculations question using definite integrals. So that is why you remember in your long answer questions there are multiple parts. So these are the type of questions that can be asked in addition to the volume calculation questions using definite integrals. So I hope you found this video informative. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.